for afterwards. All right, so good afternoon, everyone, and good morning to those joining from the US. I'm Miriam Hamam. I'm the Community Engagement Officer at MACICI. MACICI is the Moroccan American Commission for Educational and Cultural Exchange. It was established in 1982 by agreement between the governments of Morocco and the US, and we facilitate the Fulbright programs. So we're currently celebrating the 40th anniversary of the Commission, and we have started a series of webinars. And this is the 5th installment of this series. And it's going to talk about a topic that is relevant to Morocco and to the rest of the world, which is renewable energies. I am joined by 3 Fulbrighters, 2 alumni, and 1 current grantee. And I'm going to give the floor to our Fulbright alumnus, Talha, to introduce himself and then carry the conversation from here on.
Thank you very much, Miriam, and happy anniversary to MACICI. Hopefully to many more years of cultural exchange and exchange of ideas and influence. So today's topic is about the sector of energy, which is a hot topic right now in Morocco. I'll introduce myself. I'm Talha Rifaai. I'm a Fulbright alum. I came back from the University of Texas at Austin in 2020 after earning a master's in civil engineering. And I currently work in water infrastructure in Morocco. So as we move on, we'll have presentations from both Austin and Safar. And I'll start by introducing Austin first, and then he's going to go forward with the presentation, and then I'll introduce Safar, and then she can move on with her presentation. So Austin Bodetti is a researcher specializing in the culture and politics of the Middle East and North Africa. He has worked as an analyst and a journalist, reporting from Iraq, South Sudan, and Southeast Asia. Austin received his bachelor's degree in Islamic Studies from Boston College in 2018. During his participation in the Fulbright program, Austin will be studying the relationship between environmental
We've lost your sound.
Can you hear me now? Yeah, okay.
Yeah, we can.
Sorry. So Austin is studying right now and researching the relationship between environmental policy and Islam in Morocco. So please go ahead for Austin and with your presentation.
Sure, I will try to keep this short. But as Talha kindly introduced me, I am Austin Bodetti. I've often been described as Miriam's best friend, but she would definitely disagree with that. And my research in Morocco focuses on the Green Mosques program, which is an initiative that the Moroccan government ran between 2014 and 2021. So it wrapped up last year. The program was overseen by 2 Moroccan ministries. The Moroccan Ministry of Energy Transition and Sustainable Development, and the Moroccan Ministry of Habous and Islamic Affairs. And the primary goal of the program was to increase the energy efficiency of mosques across Morocco. Over the course of the program, over 890 mosques were renovated. This included installing solar panels so the mosques could generate their own electricity, LED lighting so that they used less electricity. And in one case, a mosque was built completely from scratch. It was called an Energy Plus Mosque, built in the village of Tadmemt outside Marrakesh in 2016. And it served the purpose of not only generating its own electricity, but also supplying electricity to the village. For example, thanks to the energy produced by that mosque, the village had streetlights for the first time in its history. Now, what makes this program unique is not the component that involved the energy efficiency of mosques, since other countries have pursued their own versions of the Green Mosque program, sometimes on a larger scale, like in Jordan, for example, which began its own Green Mosques program in 2014. Now, 100% of the mosques in that country produce their own electricity. Whereas in Morocco, the 890 mosques that were part of the Green Mosques program are a small fraction of the 51,000 mosques recorded in Morocco. What actually set Morocco apart was that in addition to improving the energy efficiency of mosques, the country also trained 1,200 religious leaders of both genders to identify ways in which Islam encouraged environmental protection, whether that was verses from the Quran, sayings from the Hadith, other Islamic sources, to make the argument that Moroccans and Muslims more generally had an obligation to protect the natural environment, not only because it would be damaging to the world if we didn't, but also in a religious sense. In other words, since it was God who created the world and put humans in charge of it, humans are responsible for caring for the world and making sure that they don't damage it and live on it sustainably. Overall, the program was successful in its immediate goals in terms of the number of mosques renovated, the number of religious leaders trained, but it was ultimately meant to be a public relations campaign, raising awareness about this connection between Islam and environmental protection. In that sense, it doesn't seem to have been successful or as successful, just because the Green Mosques program isn't well known in Morocco outside circles of policymakers, people working in the energy efficiency field. If you ask the average person on the street, they haven't heard about it. So my research currently focuses on identifying what were the issues with advertising this program, why wasn't it advertised more widely, and can it be expanded in the future to include more mosques in Morocco?
Interesting. Well, thank you very much for sharing the status of the project, but also what benefits it reaped and what limitations it had. So we can move on to Safar before we go to discussion, so we can have her perspective on the energy sector. Safar is has graduated with a license in computer science from the International University in Rabat in 2015. She joined Khawain in Ifran and graduated with a master's in software engineering in 2017. She also earned a PhD in computer science and mathematics at the Shuaib Dukhali University and graduated in 2021. That's when she went on a Fulbright joint supervision program grant and worked on her research at the University of Houston. Safar is currently an assistant professor of computer science at the School of Science and Engineering at Khawain University. Her research interests involve high-performance computing and its applications, including smart grids and renewable energy integration into smart buildings. Okay, so these sound like a lot of technical terms there. We'll be happy to hear more from Safar on the extent of her research and what results can be reaped from it.
Yeah, hello everyone. Thank you all for being here. I'm always happy to be part of everything organized by Masisi. It's always great to get in touch with fellow Fulbrighters. Thank you very much, Talha, for the introduction. So I prepared like this small presentation. If you can allow me, I'm just gonna go ahead and share it. Let's see.
Sure, it
Okay.
works.
I don't know if you guys can see it.
Works.
Yeah. Okay, good. All right. So, so today I will be talking about a concept. It's related to renewable energies, but it's kind of a new concept that has been trending worldwide and especially in Morocco. And it's basically the concept of smart grids or smart microgrids if we're looking at a smaller scale. So my presentation will fall under the scope of a research project where I had the chance to contribute and conduct my PhD work. I think my presentation will be a little bit technical, but I just wanted to give an overview about how these projects are actually deployed in Morocco, because our project is actually a nice blueprint or like a roadmap for other projects to be implemented. So basically, the main starting point is the environmental issue. So it goes without saying that we have a lot of environmental problems, and they're becoming more and more concerning. And a lot of countries, including Morocco, are actually making them a priority now. So these issues are mainly raised by the increase of the energy demand and the electricity consumption and production. So they go hand in hand. And a lot of countries are now opting to develop a low carbon economy in an attempt to achieve actually sustainability. That's the end goal. So it was reported that the energy consumption in Morocco has been growing by about 7% every year since 2012. So this percentage is actually a little bit alarming because this growth is expected to reach about 26% by 2013, sorry. And if we look into this consumption in details, we're going to notice that buildings are actually they play the biggest role in this consumption, and they consume up to 28% of the whole energy consumption compared to other things. So the main energy consumed by buildings goes to heating. So heating, it's a main problem for us in Ifran, and ventilators, air conditioners, and so on. So this is what we call the HVAC systems. And these HVAC systems, as I said before, they constitute the main energy consumers when it comes to buildings. So the idea here was to introduce kind of a new concept that leverages renewable energies in order to achieve energy efficiency. So this is not really a straightforward concept or straightforward solution. It's multifold, but this is supposed to help in reducing the energy consumption by about 36%. So the problem, if I want to formulate it better, I would say that the stringent demand on energy, we have a lot of demand on energy nowadays, especially in Morocco. The traditional power grids, they can no longer do the job, which means they are kind of pushed to their limits, and they are facing a lot of challenges. And these challenges are namely related to reliability, for example, because there's always a risk of failure. They're also related to quality, because we still want to reduce the energy consumption, but still keep the quality of the power that we deliver, and protection and other challenges that are actually raised and detected by the end users. Now, the solution here, as I said before, is not really straightforward. It's multifold, and it requires the implementation of a new generation of power grids. That's what we refer to as the smart grid. So when I say smart grid, so we hear a lot of smart things nowadays: the smart grid, smart buildings, smart watches. We're surrounded by smart things. But for the smart power grids, the smartness here resides in the flow of information. So we know that in a grid, there's only the energy that's flowing, or electricity that's flowing. With the smart power grids, we have also information or data that is also flowing. So this helps with decision making. This helps with the power demand and the demand response and so on. So the project I'm going to talk about today, it's a project it has a lot of disciplines combined, and the main goal here is to implement a smart microgrid on the university campus, on the campus of Al Khawain University in Ifran. And the main goal here is, of course, to reduce the energy consumption and have a better quality, and basically have all the benefits of a smart grid. So the project here, it's actually sponsored by the United States Agency of International Development, and it aims at developing a holistic approach, which means we're looking at the smart grid from different perspectives. So this approach here couples between the production and the consumption of energy, and how we can actually introduce or how we can inject whatever energy we produce from the renewables into our smart building. So we also have the smart building component here. We have a lot of partners. We're actually 4 partner universities here. We have Al Khawain University in Ifran, which is the main test bed basically, and where we're conducting pilot testing. The International University of Rabat, also University Shuaib Kali in Al Jadida, and the University of Houston, where I had the chance to do to work on part of my thesis as a joint supervision grantee. So this is our main architecture. So the main architecture, I'm not really going to go into the details because a lot of these things are kind of technical, but this architecture, we can detect 7 main components. So the main components we care about are the renewables. So we're talking here about a solar parking lot, but we did not really end up having a solar installation at a parking lot. I'm gonna explain why. We have the wireless sensor networks, we have the data part, and we have the energy part. That's basically what makes it a smart microgrid. So this is, I'm showing you now pictures of the real deployment of this project. So this project is actually still ongoing. We're still working on the project. We're still trying to get some results out of it, but I'm just sharing with you where we are in terms of implementation and in terms of findings. And I'm gonna share with you what are our future steps. So this is the solar installation that we have. It's a monocrystalline technology. And this is basically a UI campus. And this is our lab right here. So we have the solar installation that's close to our lab because we started by implementing the smart microgrid on one academic building on campus. And of course, the idea is to make the whole campus smart, and why not the whole city of Ifran smart. So this is the solar installation part. This is our lab setup, because if you have a solar installation, you will have to have or acquire the components needed or the equipment needed to deal with it. So we put in place a battery. We have our control plane. This is basically the brain of the system, let's say. We put in place also some DC and AC cabinets, but this is just what we have inside the lab. That's how we take the energy, convert it, and then we can make use of it. We also put in place a wireless sensor network because, as I said before, it's no longer just about energy. We also want to sense, send, and store information about the environment, like what is the humidity, the temperature, the motion, and so on. So this will help with the energy demand, and will also help with the demand response, basically. So this is here just a node, that's node of the wireless sensor network that we implemented. So we ended up having a couple of these nodes deployed in the entire building, and it's an academic building on campus. And we got to have the sensor or the network communicate, and we also got to gather data and store it in a database for later processing. This is very important. This is actually our actuator. So the actuator means that we can actually act on us. It's the heaters that are as I said before, the main actors. So we decided to act on heaters first, try to switch them on and off based on control algorithm. So it's no longer just manual, because we cannot really introduce any reliability, any control over this the energy that is being consumed, and when we can actually turn it on and off. So we decided to use an actuator for that and implement a control algorithm, which is very strict, follows some steps and so on. This is a very interesting part, of course, of our project. So this is where I actually contributed the most, because I'm a computer scientist. I'm not really into renewable energies that much, but I got introduced to the concept when I was working on this project specifically. So this is my biggest contribution. So we tried to have a data center. So we know that a data center is there to process data, store data, and so on. But we also tried to make it green or energy efficient. So we decided to investigate more solutions to have a cost-effective and energy-efficient data center. So this is our nano data center. So we call it nano because it's very small, but it's also doing the job. So the idea was to have single board computers instead of the commodity hardware that we know. Normal computers or supercomputers, they consume a lot of energy. So we wanted to have an alternative that would allow us to still do the processing, still do the storage, but to keep everything energy efficient. And this is just a closer look of our main plane. This is exactly what the main control is happening. So this is an in-eye compact trio. And we have algorithms there. So the algorithm in here decides on whether to, so we have energy that's coming from the solar installation. It goes through this control plane, and it's this plane that decides on whether to inject that energy into the grid or use it to power the current loads or store it in the battery, basically for future use. That's the main role of this control plane here. Now, our main results basically, so we were able to produce energy from the solar panels and inject it in the grid. We were also able to store it in the battery and get use of the battery later whenever we wanted. Of course, we get to monitor the state of charge and everything that's related to the battery. We also were able to collect the data. So again, it's like the energy part and also the data part. So we were able to get data about the environment, store it, process it, and then make decisions based on the processing that we have. So we actually believe that this project, it's a good roadmap or blueprint for future deployments of other projects, either in Morocco or in Africa or even in other countries. So we present like the steps, we present a lot of challenges, a lot of opportunities for growth, or a lot of opportunities for better deployments or like scalability for this project. So this is, regardless of the findings, I feel like the roadmap or the deployment steps that we need to take away, what we need to take away from this. And we have a lot of future tasks. As I said, it's still an ongoing project. So we still want to investigate scalability. We still want to use real scenarios to see whether we can actually, our system will actually survive. And yeah, we need also some like, we need to quantify our results for us to say that, well, this is how much we gained in terms of consumption and so on. But all the equipments are there, and we're still conducting research work on that project. So these are some of our publications that we published when working on this project. So you can check them for future, I mean, for other details, or if you can always get in touch with us if you need to know anything about our deployments. And that was it for my project, and I hope it was not too technical.
Well, thank you very much, Safar. It was very helpful to see what's behind the smart grid system as a energy sufficient system that's able to not only adjust the energy that gets from the main grid, which you can plug to, or as a system that can also store, but also level the load. And so it's a smart component that could be helpful in having a more resilient and smarter buildings that are able to not only just turn off when the electricity is not put into them, but also adapt to a more fluctuations. And as we talk about climate change, it's a world where we should anticipate catastrophes or disasters. So power outages could happen in the future. So smart grids definitely sounds like a system that could serve that purpose in terms of resiliency for cities in the future. Well, I'm interested first for smart grids in Morocco. Do you have any real world application today in a smart building in Morocco that you guys were able to deploy this in?
So our building the building that I was referring to, basically, it's a smart building on campus. So we have a couple of wireless sensor networks that are deployed, and we get to switch appliances on and off, for example, for lights, depending on the motion, if motion is detected and so on. So this was something that we implemented from scratch, that we implemented using the microcontroller, sensors and everything. So this is just a small part of making the whole building actually smart. But this is our first step. And also when including the renewable energies or integrating the renewable energies into the building makes it even smarter. Because now we no longer just rely on the power grid, the traditional one, but we also get to use the energy that we produced. So when I say we produce it, basically through the PV panels, but the PV panels that we installed and we configured and everything. So there's exactly one building that's being our test bed for now, and we're running all the pilot testing on it. It's an academic building here, and we're still trying to make it smarter. So that's kind of a real world, because this project is actually based on real world implementations. It's not only just theory or literature review and so on. So we had to acquire equipment, we had to put everything in place, and we had to start collecting results.
Okay, so do you think we're anywhere near having this kind of systems put in place in a more democratized way in around the country, or is it still a long way until we get maybe to the level where we're maybe it's a economically viable solution, but also the, I don't know about the legal or framework for it to be implemented. So how far are we from having it around?
Yeah, so when it comes to legal stuff, I think we're still a little bit behind, because I think you are allowed to have a PV panel installed in your house if you want to make it like more energy efficient. You're allowed to do that, but you're not really allowed to produce more than a certain amount of energy. So we have a lot of restrictions that are around this, but you get a little bit of freedom to like implement energy efficiency or to integrate renewable energies into your house or into your building, if like it's a company building, whatever. So you get some freedom, but it's also really restricted. So in terms of research, there is a lot of research that's being done. There are a lot of results that's being generated, a lot of good publications and so on. But if we think about like putting it in place as something that we can start working with starting tomorrow, I think we still need to work on that. We're still a little bit far from that. It's like it's still a research topic, not really into the implementation as yet.
So we're not going to see it on Austin's mosque anytime soon, right? So that I want to move on also to Austin's part about green mosques, and it'd be interesting to hear if you had any data about energy efficiency savings that were made through these projects, in terms of percentage or anything that you can share.
Yeah, so I do have a little bit. The best example is the Asuna Mosque in Rabat, where I'm based. It currently produces 80% of its own electricity and reported that it was saving about $8,000 a year in electrical costs, which is a lot of money for me. If Fulbright wanted to give me that, I certainly wouldn't complain. But in terms of one of the largest mosques in the Moroccan capital, $8,000 isn't actually that much money, which raises the larger question of, do mosques actually use that much energy? And the answer is generally no. They use a little bit of electricity for lighting, loudspeakers, things like that, but they aren't going to consume nearly as much as an office building or something like that. Which feeds into the wider idea that the main point of this program wasn't to get Morocco as a whole closer to its renewable energy goals. It was more to work as an advertisement for that campaign to increase the use of renewable energy.
Interesting. Well, following up on that, because it's also one of your research interests is to study the relationship between Islam and this environmental policies, but also energy efficiency mindset. How do you see this the argument of religion, like a religious argument, actually being an effective way of getting people to change behavior and adopt maybe more energy efficient ways to go about their lives?
I think the argument itself is strong. There's a lot of textual evidence, both in the Quran, the Hadith, other Islamic religious texts, that both directly encourage taking care of the environment, or that can indirectly be interpreted as encouraging that. And a lot of scholars have done work on this in a variety of countries, not just Morocco, but also Iran, Bahrain, even as far away as Bangladesh. The bigger question is this actually changing anyone's mind? And I'm still doing Instagram for example,
I think we lost Austin.
where it looks like trained. Sorry, where did it cut off?
Yeah, your internet is breaking off. I think you're back. Okay.
Yep. Where did it cut off?
Well, just your last sentence, basically.
The two reasons I think this argument hasn't been very effective from a practical standpoint is that there's not a lot of evidence that being told something in a religious sermon will necessarily influence someone's behavior. As far as the Green Mosques program, there hasn't really been a lot of follow-up of the 1,200 religious leaders who are trained. Are they still incorporating pro-environment ideals into their speeches? Have they continued to be encouraging people to do that? And then on the wider level, environmental protection and especially energy efficiency is largely something that has to be done at a government level, not an individual level. Projects to increase the use of solar power, for example, require a lot of government funds and sometimes even foreign funds. As Safar mentioned, the work that she was doing was partly financed by USAID. Same thing with the Green Mosques program. 70% of the funding came from the Ministry of Islamic Affairs. So I think there is a place for integrating Islam in environmental protection, but it's just a smaller component of the government action that's needed to reach energy efficiency goals, both in Morocco and in other countries.
Okay, so do you see this the Green Mosques program as a because we know Morocco has been engaged in this energy strategy since probably officially in 2009 when it launched its ambitious goal of having almost half of its electrical installed capacity coming from renewables, and at the same time developed this strategy of having efficiency, as Safar mentioned about where we consume, well, like just a 20% decrease in consumption thanks to energy efficiency measures. Do you see this kind of initiatives, because you say they don't play a big role in terms of like the actual numbers and objectives of the government? Do you see them just as a way that the government wants to encourage people and just develop it, start working maybe on the habits of people to prepare maybe for a later phase where we do get to the level where these habits can actually make a change and get to the last mile of goals maybe that we'll want to reach as a country?
Yeah, I think you hit the nail on the head of the Green Mosques program was meant more toward encouragement rather than improving the bottom line of energy efficiency in Morocco in its own right. Since I think its contribution to Morocco's transition to renewable energy on a national scale was probably pretty limited.
Okay, so maybe this is an open question for both of you. As you guys work on these energy topics, I mean, I mentioned this parallel between mega projects that the government is involved in, and we have these initiatives that target energy savings. Do you see, as you work on the field and talk to people, do you see a disconnect between what people think of this energy measures compared to their lifestyle, or as opposed to like the big projects that the government is leading?
I would say, oh, go ahead.
Okay, go ahead. Yeah, go ahead.
With the Green Mosques program, the disconnect is just not a lot of people have heard about it. unless people were already working in the renewable energy field or working for the Moroccan government. And with people going about their lives, I think there's bound to be a disconnect, just in the sense of we can all make a small difference with energy use, of taking shorter showers, not leaving the lights on after we go to bed, things like that. But the biggest steps toward increases in the use of renewable energy or improving energy efficiency are going to come either from the scientific community through work like what Safar is doing, or from the government and investments in large projects like the Noor solar power station and where's is that. Those are going to lead to big jumps, whereas I think what the individual can do in this sense is very limited.
Do you want to add something?
Yeah, I actually agree with what Austin said. So this there is like ongoing work that's going in the direction of saving energy and having more energy efficient buildings and so on, but this also requires the collaboration of people, because you cannot really tell them that I'm putting in place a smart grid then allow you to consume more energy, allow you to get a better quality of the electricity and so on, and then they can keep on with like again using the energy, using the resources irresponsibly. So yes, we have renewables, it's meant to be sustainable, but it's about more education for people who are going to be using these systems, or just to tell people there are actually some work that's being put in place that's aiming for this, like that's going in this direction of having more energy efficient buildings now with the e-vehicles and so on. So we have a lot of work. It's still research again, but we're still trying to put it in place. So people need to be aware of the work that's being done, which is not always the case. So for example, for smart grids, I worked a lot in this topic, and then I'm like, okay, so everyone should know about smart grids. Everyone should know about this this concept, but it's not really the case. So people should know that yes, the traditional grids that we have, they're doing the job now, but the demand it's getting more and more crucial. So we need to deal with it, and we have to have a new generation of power grids that's supposed to deal with it. So this is just to tell people that this is where we're going, this is where we're heading, and this is exactly what we're trying to do. So telling people about what's happening in terms of the efforts that are being put in place, I think that's what's gonna bridge the gap between, or make this disconnect not existing anymore.
On the sound of that there, and also based on what Austin said earlier about advertisement being a problem. And so there's clearly a big need on spreading the word on what's being done to raise awareness, but also promote the right habits and behaviors from people. So what do you think was the problem, Austin, as you start investigating this advertisement problematic?
In terms of why it wasn't advertised?
Yeah.
To be completely honest, I'm not sure. Most of the information that I found out about it has come either from the foreign press, specifically the non-Moroccan press, or from documents published by the German aid agency that was involved in assisting with the installation of solar panels on the mosques. The Ministry of Islamic Affairs has published information about the connection between Islam and environmental connection, but it has not put out a lot of information about this program. Again, to be honest, I'm not sure why that is the case. The program was advertised to an extent because foreign journalists have reported on it. But the main audience of the program, I would think, would be Moroccans or Muslims more generally, not necessarily foreign journalists. And I'm not really clear on why the program wasn't designed to be advertised more to them. There's not even a central list of mosques that were included in the program. Of the 890 that were renovated, only identified.
Okay. So maybe I'm thinking like we have this several initiatives that are going. There's some in research, some on our grassroots level in smaller communities. So how do you guys think we can learn from these experiences? Do we have enough of platforms to share the lessons learned and just kind of build on this experience and grow from there?
So I think I can talk about the case of the project that I was working on. So to be honest, to start with, we faced a lot of challenges because we did not really know whether the same project was being deployed somewhere else, which we then discovered it was the case. So we struggled a little bit with acquiring the equipment, with installing the equipment and everything. So we also made sure that whatever challenges we face, we also want to let people know about that. It's not only the findings that are important, but it's also the challenges that we faced in order to achieve whatever findings we have. And that's why in our publications, like all the publications that we put in out there, they delineate exactly what we went through. Like these are the deployment steps, these are the challenges, this is what can go wrong, this is what can fail, and so on. So yes, it's a small initiative, but when we started it, we would have loved to have some support, or like something to start with. There was some work that's been done. We did the literature review and so on, but it was not really that helpful. That's exactly why I said we have to delineate everything in our publications. So for us, since it's just research, it's mainly a research project. Our main platforms are the journals, or the databases, the libraries, and so on. So that's why I invite everyone who's working on research to be more open about what they're doing, to give as many details as they could, because it's like given to the community. So we want to deploy the same thing, but we don't want to go through all the difficulties. Yeah, so for us, for our research project, or for research in general, it's mainly the publications. That's how you would let people know what you have and what you went through.
Yeah, as far as mosques specifically, I would say the mechanisms are already there. The Ministry of Islamic Affairs and the Ministry of Energy Transition have already shown that they know how to run a program to improve energy efficiency. The Ministry of Islamic Affairs also oversees a total of 15,000 mosques, or a little under a third of the mosques in Morocco. So there's definitely potential to expand the program or run a similar program. I think, again, the question will just be raising awareness, and the best way to do that, which is also a problem that the mosques can be the answer to, of raising awareness of the connection between Islam and environment. During Friday prayer, for example, that's something that the 1,200 religious leaders who are trained already did, but that's a small fraction of the total number of imams in Morocco speaking every Friday. So they could also be integrated into the program.
Interesting. I don't know, Miriam, if we have other questions from attendees.
Yes, we did receive a question in the chat box. I'm going to read it, but you guys can click on the chat box and read it too. But it says, does the Green Mosque program include other aspects of green/sustainable design that improve energy sufficiency besides installing solar panels on the mosque roofs, such as better insulation, passive energy systems, green roofs, etc.?
As far as I'm aware, the only elements were solar panels and LED lighting. So it was about creating more electricity and decreasing the use of electricity for lighting. But as far as insulation, for example, to decrease the use of electricity for heating, I don't think there was any component that includes that. So that's another area where the program, if it is expanded in the future, could be improved.
All right. Before we close off, I think if you would like to give your opinion on the ongoing debate on whether smaller countries with low CO2 emissions should be held to the same standards as bigger countries who benefited from years of industrial development.
I would say it kind of depends on the country. I think that Morocco, whose consumption of fossil fuels is relatively low compared to the United States, for example, shouldn't be put under the same pressure as China, for example, that came to the heavy use of fossil fuels a little later, but is now the largest emitter of greenhouse gases in the world. So I think it's a question that has to be handled on a case-by-case basis. But generally, I would say smaller or less wealthy countries that depend on fossil fuels for their development shouldn't necessarily be held to the same standards as Western countries that began using fossil fuels on an industrial scale much earlier, and that are still major contributors to the emission of greenhouse gases.
Yeah, I actually agree with Austin. It's like a case-by-case problem or something to discuss. But I believe that even for smaller countries, it's a matter also of projection, because now you're not really consuming a lot of energy, or you're not really producing a lot of CO2 emissions. But with the development of the industrial developments, we're witnessing novelties basically in all aspects every day. So it's also a matter of projection. So to see where we're going to stand 10 years from now or 20 years from now. So that's also need to be taken into consideration. But yeah, I mean, if we're talking about the current status or the current state, it's basically, it needs to be processed on a case-by-case manner.
Yeah, I think for the COP27 that just ended lately, one of the big achievements was the loss and damage fund that was set up as a way to compensate developing countries for the damage that has been done by the developed countries, and that was quite the achievement as they way to kind of put everybody in the same level and move forward. Just compensate people for what happened in the past, and then move on to what's coming in the future, because what's coming in the future is a market where it's going to be hard for even developing countries that don't want to make the choice to decarbonize or phase out their fossil fuels. It's going to be hard to be competitive in those markets, and Morocco is one case, because the European market is going to put on there's going to be the carbon tax that's going to be implemented, and Morocco, that was one of the pressures Morocco has to decarbonize even further and phase out its fossil fuels. So it's good that the international community is moving towards a solution, and it certainly isn't fair for developing countries to deal with the consequences of climate change on their own, considering like the industrial era that we had in the past.
All right. Well, on that note, I think we can end our webinar. Thank you to our panelists for a very informative session. And thank you to our attendees for taking the time to join. Have a great day, everyone, and I hope to see you on the next one.
Thank you.